Welcome back, everyone. Whether you're deep in the plastics industry, maybe working in masterbatch manufacturing, a color matching lab, R&D, quality control, or you're a CPET student, today's breakdown is going to be incredibly valuable for you. In our last analysis, we took a really close look at the spectrophotometer itself. But, that brings up a massive question for anyone actually walking into a lab. The machine measures the color, sure, but how do you actually operate the whole system? Why are there just so many options in the software? And what do all these metrics actually mean? Today, we're answering all of that by taking a comprehensive look at the X-Rite Color tool, and we're going to ground everything we discuss in real, everyday industry examples. Okay, let's dive into this. Here's our roadmap for today. We'll cover the color management system, real industry workflow, dashboard tools, the reflectance curve, production troubleshooting, and finally, QC best practices. Let's kick things off with Section 1, the complete color management system. Before we get into the technical weeds here, we really need to clear up a common misconception about what this tool actually is. A lot of folks starting out think the X-ray is just a machine, right? Just a spectrophotometer sitting on a desk taking readings. But the reality is, it's a comprehensive color management system made up of 3 distinct parts: the spectrophotometer itself, the computer software, and the color database. Together, these 3 elements control the entire color matching process. Out in the industry, the machine merely takes the physical reading. It's the software that actually makes the critical decisions, and it's based on those intelligent decisions that the R&D engineer is able to tweak and improve their formulation. Moving right along to Section 2, the real industry workflow. Let's look at how this plays out in an actual day-in-the-life scenario on the factory floor. Imagine an automotive customer sends you a gray dashboard part and gives you a very clear demand. I need you to manufacture this exact same color. Well, here's the step-by-step physical journey that sample takes once it hits your lab. First up, the lab engineer receives it and meticulously cleans it. We're talking about removing every single fingerprint and speck of dust. Next, the machine has to be calibrated, which requires both a white and a black calibration. Once that's all set, the sample is measured. The software then automatically saves all the crucial data: standard name, date, operator, batch number, LAB values, reflectance curve, the whole shebang, along with the tolerance. From there, the R&D engineer steps in to formulate the master batch by picking the right pigments. They mold an injection sample, measure it again, and literally repeat this entire cycle until they perfectly hit the customer's tolerance. That's the real rigorous workflow out there. Now for Section 3, inside the software dashboard. Okay, so we're now looking directly at the screen the lab engineer relies on every single day. The very first thing you'll probably notice in the software are these 2 distinct categories: standard and sample. The standard is the customer-approved color. This is absolutely sacred. It never changes. It's our absolute reference point. On the flip side, the sample is the actual color coming out of our current production batch. So every single batch we produce is constantly being compared back to that untouched standard just to ensure total consistency. Next up, the software automatically spits out the LAB values. Just as a quick refresher, L represents brightness, A represents the shift from green to red, and B represents the shift from blue to yellow. This is fantastic because it brilliantly illustrates exactly which direction a color has shifted. By just glancing at these 3 simple values, an engineer instantly understands how the formulation has drifted and, more importantly, precisely what their next intuitive move needs to be to pull that color back on target. But honestly, of all the metrics on the dashboard, this next one is perhaps the most critical for an engineer, and that's delta E. Delta E represents the overall color difference between your perfect standard and your current sample. The rule here is incredibly simple. A lower delta E number means a much, much better match. To put this into perspective, the automotive industry requires an extremely low delta A. They maintain incredibly strict tolerances to guarantee flawless quality control across all their parts. There's virtually zero room for error here. If your delta A creeps up even just a tiny bit, you better believe that dashboard part is getting rejected. Thankfully, though, you don't have to guess. The software automatically makes the final call for you. If the sample is within that strict tolerance, boom, it displays a green pass. If it's outside the tolerance, it slaps you with a red fail. It's strictly on this basis that quality control will either release the production batch or hold it back. It literally takes all the subjectivity right out of the equation. Which brings us to Section 4, mastering the reflectance curve. Now, this next feature is the absolute secret weapon of experienced color matchers. Let me ask you something. What happens if you have 2 samples and the delta E is totally identical? But when you take them outside into the sunlight, the colors look completely different. Wild, right? Well, this phenomenon is exactly why just looking at the overall color difference is not enough to guarantee a perfect match in the real world. And that is exactly where the reflectance curve comes into play. It's basically a graph that shows exactly which wavelengths of light are being reflected by your sample. Automotive companies don't just look at delta E, no way. They strictly analyze this reflectance curve. They need to ensure that the gray dashboard matches not just under the bright fluorescent lights of the lab, but out in the midday sun or, under a street lamp at night. All right, moving into section 5, troubleshooting real production issues. This is where we transition from normal daily operations into the high-stakes detective work of solving customer complaints. Imagine the phone rings and the client on the factory floor tells you, the batch color is coming out too dark. What do you do? Well, the engineer immediately takes a reading of the sample in the machine. And sure enough, the data shows that the L value, the brightness, is coming up too low. Now, the rapid detective work begins. A low L value could actually be caused by a bunch of different things. It might be an excess of carbon black in the mix, or maybe too little titanium dioxide. But here's the catch. It's not always the formulation. It could be a high processing temperature causing issues, it could be material degradation, it might just be poor pigment dispersion, or even a high residence time inside the machine itself. The engineer has to compare the machine's color data with the actual production data to hunt down the true root cause. This whole process is known as root cause analysis, or RCA, and it ultimately leads to corrective and preventative action, which we call CAPA. This brilliantly illustrates that the tool doesn't just passively measure color, right? It actively helps engineers diagnose manufacturing defects and implement permanent lasting fixes right on the floor. And finally, Section 6, Industry Best Practices for QC. These are the uncompromising daily habits that practically guarantee success in any color lab. Real industry engineers absolutely swear by these rules. You must calibrate the machine daily. Samples must be impeccably clean. You have to use consistent sample thickness and identical molding conditions every single time. Always select the same illuminant, take multiple readings to find an accurate average, protect your calibration tile from scratches like it's literally made of gold, and, of course, regularly back up your software data. So the crucial point here is that maintaining these small, highly disciplined practices is absolutely the only way to achieve true color consistency, day in and day out. When you put all of this together, the hardware, the software, the troubleshooting, and that strict daily discipline, you start to realize just how powerful this system really is. If you're looking to build a serious career in the plastics industry, masterbatch manufacturing, compounding, or quality control, deeply understanding this complete tool is a non-negotiable essential skill. It elevates you from someone who just runs basic tests to an engineer who actually solves complex problems. We've covered a massive amount of ground today, from the fundamentals of LAB values all the way to the complexities of the reflectance curve. But you know what? There is still so much more to uncover. Are you ready to master real industry tolerances and customer approvals in our next analysis, where we'll focus entirely on the intricacies of delta E and color difference? I honestly can't wait to share it with you. Until then, keep analyzing, keep troubleshooting, and I'll see you in the next explainer.